Hello everyone. Today we are going to see question called profitable schemes. So this is a question number 879 on lead code, and yes, quite interesting question. Yes. So what the question says is there is a limit of peoples called n. Okay, so n is equals to 5. So we can have a group of 5 peoples together only. Okay, not more than 5. Okay. So then we have a minimum profit, and we have a one array called group and one array called profit. Okay, so what is this group and profit is like the group of I makes profit of I. Okay, so this group of two peoples make profit of 2. Okay, this group of 2 people make profit of 3. Okay, so yes, so this is the question. So we have to find number of possibilities. Okay, we have to find the number of possibilities where we can make this minimum profit. Okay, so in this question we can make a minimum profit using this group of two peoples, that is group of 1 which is 2, which makes profit 3. So this is one possibility, and another one is we can use this group of 4 peoples. Okay, that is group of 0 plus group of 1, which makes together profit of 5, which is also greater than 3. Okay, so there are two possibilities. Yes, so we have to written the number of possibilities where uh, the subgroups, the subarrays of this group can make the minimum profit of 3 or maybe greater than 3. Okay, and the number of people in a particular group or a particular combination or a particular subarray should be less than or equals to 5. Okay, so this is the question. So let's see this example. Here n is 10, minimum profit is 5, and we have a group array of 2, 3, and 5, and profit array of 6, 7, and 8. So here in the profit array, all the numbers are greater than 5. Okay. Yes. So what we can do, we can take individually every group. Okay. Like the group of 0, which is a group of 2 peoples, makes profit of 6, which is greater than 5. Then group of 3 peoples make profit of 7. Then group of 5 people make profit of 8. Okay, or we can take this group of 0 plus group of 1, that is 2 and 3 together. Okay, which is less than 10, which make profit greater than 5. Okay, yes. So here minimum profit is what? 5. Okay, it can be anything beyond 5, but it should be greater than 5. Okay, so for comparison we have to take this 5. Okay, like if it is greater than 5, it's okay, but it is less than 5, then it is not valid. So here are the all the subarrays, that is all the possibilities that we can make from this array of group. So these are indices. We can take individual indices, that is 2, group of 1 is what? 3, group of 5 is what? 2, and we can take the combination of 2, 2. Okay, 0, 1, 0, 2, and 1, 2, and all 3 together. So there are 7 possibilities. Yes. So let's see the logic. So here it's quite related to a zero and knapsack problem, because here we for every group or for every profit we have two possibilities whether to take or not to take. Okay. So here if we go with this 2, so we have the possibility that we take 2 and we does not take 2. Okay, if we take 2, what is the profit? Profit is 2, but it is what? Less than 3, so we cannot count that possibility. Okay, so then that the further branch will further in the recursion tree, it further goes to take the further element which is also 2. Okay, and not take 2. Okay, so one possibility will be 2 comma 2, which is a group of 4 peoples and make together profit of what, 5. Okay, which is greater than min profit. So that is one possibility. And here, if we take individually these 2, it make profit of 3, which is equals to min profit. Okay, so that is also one possibility. So overall, if you draw the recursion tree of this question, you'll understand that it is quite the variation of zero in knapsack problem, and quite equivalent to that only. Like every member, for every member you have a possibility, for every group of member you have possibility whether it has to take or has to not take. Okay, yes. So, and we have given here that we have to return our answer in modulo 10 raised to 9 plus 7. Okay, because answer may be very large. Yes, and yes, so we declared one DP of 3D DP. So why we have taken here 3D DP? Because three elements are varying every time. Yes. So what are that three elements? So we have taken a DP of I, J, and K. Okay. So what is I? I is for number of peoples. Okay. So for every possibility, there are different number of peoples. Okay. Then K is what? K is a minimum profit. Okay. So every time the profit is varying. Okay. So that means we have to track that profit. We have declared a K. Okay. And for the group index, for iterating to the group array to take number of groups to decide whether to take or not take, we have declared a J. Okay. So here is the 3D array, 3D array of DP, and the limit for every element is what? 101. Yes. Yes. And so here one possibility, like here a minimum K, minimum profit is what, our K. So minimum profit can exceed the 101. Okay. So for that, we'll always do minimum of minimum profit, comma K plus profit of J. Because what is our concern? Our concern is minimum profit should be greater than or equal to 3. Okay. It can be anything beyond 3, but our upper limit is what, 3. It should, sorry, our lower limit is what, 3. It can be anything beyond 3. Okay. So so if it is like greater than 3, we can consider 3 for comparison now. So we'll take this minimum of minimum profit, comma K plus profit of J. If this K plus profit of J is less than this minimum profit, so it will be stored in K. Okay. But if it is greater than, then we'll take minimum profit only. So why we have written that? To not violate this limit of 101. Okay. So yes. So let's look to the function. So we have declared DP and we set every element of DP to -1. And then we have declared one solve function, and which take parameters of I, int j, int k, and int n, which is a maximum number of limit of group of people, then minimum profit, then vector of group, and vector of profit. Yes. So if j is equals to group size, j is what we are using j for iterating a group. Okay. So if j is equals to group size, what we'll do, we'll check a condition that our k is what, profit, is greater than or equal to min profit, and our I is what, number of people, is less than or equals to n, then we'll return what, 1. Else we'll return what, 0. Okay. And another condition is if our group of people, that is I, is greater than n, that means this is greater than this phi, so we'll return what, 0. Then we'll check that the function counting for the ijk, which if it is already calculated and stored in DP, then we'll return that answer to the function. Okay. And then we have declared here two variables, not selected and selected. Okay, two possibilities. So every member has two possibilities, whether it is selected or not selected. Okay. So we have declared that to 0 initially. Then this not selected, we will do solve I. So I is, if it is not selected, the number of people will not change. Okay, number of people will be as it is, so I will be as it is. Okay, and the index for the next time will go to the if it is not selected, we'll go to the next index. Okay, so we have done here k plus j plus 1. Okay, and the profit will also be same, so k will also be same, and another n minimum profit group and profit will be as it is. Okay, and then if it is selected, okay, so we'll check that I is लेस देन और इक्वल्स टू एन, कि जो ग्रुप है लोगों का वो एन से कम है या नहीं, वो हम इस कंडीशन में देखेंगे। और फिर सिलेक्टेड क्या होगा, सॉल्व, so number of people will be increased by what, I plus group of j. Okay, then we'll go to next index by doing j plus 1, and for tracking profit, that is k, we'll do minimum profit profit comma k plus profit of j. Okay, and all these things as it is. Okay, so this is not selected and selected, and finally we'll return dp is equals to selected plus not selected. Okay, so we have to return the both possibilities. Okay, because the selected and not selected are both counted as a possibility now, so it will check here that the profit is valid or not. Okay, but that's why we have to count both selected and not selected. Okay, maybe not selecting that particular element can also result to the validate test case. Okay, test case, so we have to count both selected and not selected, and finally we'll return selected plus not selected, and we'll mod it by 10 to the power 9 plus 7. Okay, to deal with the large answers. Yes, so that's it for this question. So let's run the question. I hope you understand this minimum of minimum profit plus k plus profit. See, we need here minimum profit to compare. Okay, if it is greater than minimum profit, we can consider it as minimum profit. But if it is less than minimum profit, if the value of k is less than minimum profit, then we have to take that value only. Okay, if this k plus profit of j is less than minimum profit, then we'll consider that value only. But once it crossed the minimum profit, we can consider it as minimum profit, because it can be anything beyond minimum profit, but our concern is only to that lower limit. Okay, yes, so let's submit. Yes, so that's it for this question, and the time complexity of this question is O of I into j into k, and the same space complexity is also O of I into j into k plus some recursive stacks. Yes, so this is the top-down approach of solving this question. You can solve this question by bottom-up approach also. And yes, that's it for this question. I hope you like the solution. If you like it, please hit the like button and subscribe to the channel. And yes, happy coding.